All right, hello and happy Friday. It's the end of your first week, and I hope it's going okay. Um, Lots of stuff, right? Classes. I don't know how you feel about your classes and Canvas and all of this stuff. I hope you guys are all healthy and doing well. So anyway, yeah, let's dive right into it. Again, thank you for those of you who turned on your cameras. It's much appreciated. I enjoy seeing your face. So thank you. Today we'll talk about subsetting. I think you guys are familiar with subsetting. We'll talk a little bit about some of the quirks, some of the things that happen, and we'll look at subsetting vectors and matrices and data frames and all of that good stuff here. So first we'll talk about just subsetting a vector. A vector, I think you are familiar with this, but let's take a look at some of the stuff. So I've got this simple vector x. X has the values 2.1, 4.2, 3.3, 5.4. They are not in order from least to greatest. But the value after the decimal, the 0.1, the 0.2, the 0.3, and the 0.4, that is in order, going from kind of the first position, second, third, and fourth positions there. Okay, so we can subset using integers, positive integers, negative integers, character vectors, stuff like that. So if we subset with a positive integer, it's going to return the elements at those specified positions. So here, if I say, give me back the third element and the first element, then I'm going to get 3.3, 2.1. Okay, so we're going to get that, right? Third element and the first element. There's a function called order. The function order, what that does is it gives you back the indexes if you wanted to put the vector in order. So here, order x will give me back 1, 3, 2, 4, which says if you want to put this thing in order, first you need the first element, then the third element, then the second element, then the fourth element. And so if I subset x using the order, then it will be in order from least to greatest, 2.1, 3.3, 4.2, and 5.4 in order from least to greatest. When you subset, you can technically put in the same index multiple times. So you can do like x in that. So now I'm combining values. I'm going to do like x 1, 1, okay? And then it's going to give me back the first element multiple times. Every time I ask for the first element, it gives me back 2.1. If you put in, so generally it's expecting integers, right? If you give it something that's not an integer, it's going to truncate it to be an integer. So if I give it 2.1, I give it 2.9, it truncates those values to basically the integer 2, and it gives me back the second element. So it's not going to round. So you give it 2.9, it's not going to round. It just gives you, it truncates it to 2. Now, this is not something you are normally going to do. You don't normally intentionally give it a decimal value and say, I want to subset this with this decimal value. But it could happen, and you got to be careful. You could say like, okay, well, which values should we select? And maybe you do some kind of calculation. You're going to say, well, we've got, I don't know, if you were going to do some kind of weird thing where you're going to try to find the quantile, the first quartile using some kind of formula, right? You can say, well, I've got 120 elements. I'm going to do 120 divided by 4. And therefore, I'm going to get like the 30th position, okay? But then what do you do if you have like 121 values? So you say, well, okay, I want the first quartile, 121 divided by 4 and stuff like that. And you might end up getting some kind of decimal value. And you might think that that you're going to select something based on that, but it could end up not being, say, 3. It could end up being like 2.999, and you end up selecting the second element. So just be careful, okay? Just be careful. You can put a minus sign in front of any kind of vector, and it will basically say, I want everything but I want everything but, okay? So here I've got everything but the third and first elements, okay? So now I get the second and the fourth elements, 4.2, 5.4. This is very useful if you wanted to kind of create two sets that are complements of each other. So a lot of times we want to do like a training set and a testing set. So how do we do this? Well, maybe we have the indexes of the test set. We might say the test set is going to be the 5th, 7th, and 12th elements. And for the training set, you'll just do everything but the test. It'll be, you'll subset, you'll say training is X minus the test indexes. So everything but the 5th, 12th, and I forget when the values I was saying, 5th, 7th, and 12th values. You can't mix negative and positive integers. This is ambiguous and confusing. So we're basically saying, I want everything but the first element, -1. I want the second element. And then it says, well, what am I supposed to do about the third and fourth elements? Do you want those? Do you not want those? It's ambiguous. And so R says, I don't know what I'm supposed to do. It gives you back an error. It complains, and it's not going to, it says, I think you made a mistake. Subsetting with a logical vector. This is one of the most useful and handy things that we can do when it comes to subsetting. We can create some kind of logical statement, like a comparison statement, like x greater than 3 or something like that. And the result of x greater than 3 is going to be a logical vector of true and false values. So basically, when there's a true, you get those values back. When there's a false, you don't get those values back. So here, if you have a logical vector directly, true, true, false, false, we're going to get back the true and the true, 2.1, 4.2. We don't get back 3, 3, and 5, 4 because those are aligned with the false. Here, I put in a statement, x greater than 3. X greater than 3 is false for 2.1. It's true for these three values, 4, 2, 3, 3, and 5, 4. So we're only going to get back those values, 4, 2, 3, 3, and 5, 4. If the logical vector that you are using is shorter, then it gets recycled. So here I've got 2, 1, 4, 2, 3, 3, 5, 4 is x, and I'm going to subset using a logical vector with true, false. Okay, this logical vector is length 2, and so it basically gets recycled to true, false, true, false. And so I'm going to get back the first and the third elements, 2, 1, and 2, 3. If there's a missing value, as far as the index goes, the missing value will always return a missing value. So here I say I want the first element true, the second element true, missing value, last one false. So I get back first element, second element, missing value, false. Don't get that one. Recycling rules still apply. So if I say true, comma, NA, 2.1, true, NA, 3.3, NA. If you include nothing inside the square brackets when you're doing a subset, nothing will give you back the original vector. It'll give you back all of the things. We don't really do this when we're dealing with, I mean, there's no rule against it, but it's not so handy when you're dealing with a vector, but it is very handy when you're dealing with a matrix, okay? And because in a matrix, you might want to say, oh, I want all of the elements in this particular row. So putting in nothing there is handy. And then if you put a 0 in there, you're going to get a 0 length vector as the value that results. Okay, this doesn't often happen, but it can be useful to kind of generate a test case where you want to say, well, what happens if I end up with a 0 length vector? Is this going to cause my program to crash or something? Let me go ahead and give you your first view quiz answer for today. Today's first view quiz answer is the letter B. B as in bear. B as in bear is your first view quiz answer. If the vector is named, then we can start using character matching, character vectors to keep track or to subset. Okay, So the way names are stored in R is via the attributes. Okay, so names are stored with attributes. Let me just delete everything out here. So let me, I have to go back to the slides. Okay, so here's X. We're going to set names. We'll take X, and we're going to set names on X, and we will produce Y. Right? So Y is a named vector. And so if I say, what's the type of for Y? It's a type double. The values are double. But if I ask for the attributes of Y, the names A, B, C, and D are stored in the attributes list. Okay, so the names A, B, C, D are stored there. So anyway, I can say, give me back from Y, the subset, give me back the elements with the names D, C, and A. And indeed, it gives you back 5, 4, 3, 3, 2, 1. The elements associated with the names D, C, and A in that order. Just like the integer indexes, if you repeat a value, an index, it will do it. So you can say, I want A, and A, and it will give you back 2, 1, 2, 1, 2, 1. When you subset with names, the names have to be spelled exactly right. So here I'm creating a vector Z. Okay, and it's got the names A, B, C, D, E, F. And so if I say I want A, it's not going to work. Okay, you have to give it the true name. The name has to match completely. And so here, if I say I want just A and I want D, it gives me back NAs. It says that those things don't exist. We don't have anything like that. So one application that's really handy is this this idea of making a lookup table. So here I'm going to make a new vector X. And it's just it's a character vector with the letters M, F, U, F, F, M, M. Okay. And let's say I want to say, well, you know what? I want the full thing. I don't want just M. I want male, and I don't want just F. I want female. And for you, I want to put in missing value or something else. Okay. And you know, this could be useful, especially if you have data and things are being coded. So I think, you know, there's a popular data set with airlines and or flights, and the airline, the carrier is coded using this two-letter abbreviation, right? Or you can even just think of your states, right? And if you're not from the United States, you might not be familiar with all of the postal abbreviations, right? You've got AK and AR, and you know which one's Alaska, and which one's Arkansas, and which one's, you know, what are all of these different things that have different state abbreviations, or for the airport, you know, what are these carrier abbreviations? It might be handy to have a lookup table. So if you want to say, okay, you know what, we're going to create a vector with the values that associate them. Okay, so here is I'm going to create a vector called lookup. And what does lookup look like? Lookup, there's only 3 elements: M, F, male, female, NA, and they have corresponding names, M, F, and U. The names for lookup are M, F, and U. And so what I can do is I can subset lookup using this length 7 vector of X. So again, X is all of these things. I can subset lookup using this. And now it's going to, again, every time it sees the M, it pulls up male. Every time it sees the F, it pulls up female. Every time it sees the U, it pulls up NA. And it has no problem repeating. And so we get all of this. And if we want to get rid of this top row of names, we can just unname. We can just say, get rid of the names using unnamed. And now the values have been kind of expanded to their full values rather than just the abbreviated single initial letters. So this is kind of handy, having a lookup table in this way. Okay, let's talk about lists. The way we subset a list, so remember, a list is still a one-dimensional structure. It's just you can nest things inside a list. It's a lot like subsetting an atomic vector. But we've got single square brackets and we have double square brackets, okay? The single square bracket, when you subset a list with a single square bracket, it's always going to return a list. And when you subset with a double square bracket, it extracts the object inside of the list. So a common analogy or analogy I like to use is I like to think of a list as kind of a train, okay? A train of different cars. Each element in the list is its own little train car, and those train cars might contain vectors or different lists or different objects inside of them. And so when you use a single square bracket, it returns the train car itself. It returns the train car. So it's always going to return a list. It's going to return the list object, the list elements itself. If you use a double square bracket, the double square bracket will give you the object inside. So x double square bracket 5 will give you the object inside train car number 5. Whereas x single square bracket 4:6 will give you a train with cars 4, 5, and 6. Let's take a look at a few examples. And I hope to have all of this cleared up, and I hope this all makes sense. And this might take a little bit of time to get used to, but I'm going to start by creating a list here. I'm going to create list A. Oops. Okay. A is this list. And so I'm going to just draw what this is. Okay. So A is a list, and we're going to say it is a train car, and the first element is X, and the second is another train car named Y. Inside X, we have 1, 2, 3, 4, and inside Y, I have 9, 8, 7, 6. So A double square bracket 1 is the object inside. 1, 2, 3, 4. A $Y is going to be the object inside, 9, 8, 7, 6. Or a double square bracket with the name Y will be the object inside. When you use double square brackets, it gives you the object inside. If you don't use double square brackets, if you use single square brackets, okay, so if I say a single square bracket, and I want, so if I just say single square bracket X, what this will give me back is it'll give me back the train car with 1, 2, 3, 4, right? And so when I say, I need to draw this again. If I say a single square bracket C, Y, X, and X, okay, with the single square brackets, it's going to give me back a train of length 3. And I've got Y, I've got X, and I've got X. This is going to be 9, 8, 7, 6, 1, 2, 3, 4, 1, 2, 3, 4. Okay. I can't double square bracket YX, right? So if I say double square bracket, this will say I want the contents inside Y and the contents inside X. And R won't let us do that. Because inside the trains, I mean, right now I've got these numeric vectors and I could combine them, no problem. But inside a list, you can put in other lists. you can put in functions, you can put in data frames, you can put in any kind of object inside a list. It's basically a train car. You can put anything you want. And so what if we said, hey, I want to combine y, a numeric vector, 9876 would say, and what if what was inside train car x was a function? I want to combine it. Well, we can't do that. Okay, so R doesn't let you do kind of extracting these things and combining them. And in fact, when it sees something like this, it does something called recursive subsetting. That's how it avoids the issue. And so over here, I've created a list A. I've created a new list A. There are two elements in it, okay? We've got X, which has the vector 1, 2, 3, 4 inside. And inside the second element of the list, Y, I've got another list. Okay, and this one, I've got X, which has character A. And I've got Z, which has character B. Okay, and so when you ask, what is the structure of A? It basically has this diagram here, but just in text form. It says your first element of the list is this vector, is this first train car X, which contains this integer vector 1, 2, 3, 4. Okay, and then in the second train car is Y. Inside that is another list, is basically another little train. And the first, it's a list of 2 with elements A, with a character vector A and a character vector B inside the second thing there. And so here, when I say subset, and I want this, okay, this is going to return basically this box here. It returns back the contents. The double square bracket will return what's inside the box. Okay, what's inside the box, which is going to be $X, $Z, which contains A and B. And so now when I do double square bracket Y, double square bracket X, now it's going to basically pull out this element, which is going to be the letter A. Does that make sense? What's happening here? So the double square bracket pulls out what's inside the train, whereas the single square bracket pulls the entire train car, This thing right here, Y comma X is equivalent to this. These two things are equivalent, and that's why we're getting the same value here. When you have a vector C, Y comma X, it's going to do recursive subsetting, and it will return this. All right, we're going to make things more complicated. Here's a vector. I'm sorry, not a vector, a list D. It has 3 elements, A, B, and C. Okay, so basically a train of length 3. First train car has 1, 2, 3. Second train car has true, true, false. Third train car has the character A. With the single square bracket, it returns back the first entire train car. All right, so I've got 3 train cars, A, B, and C. 1, 2, 3. I think this was true, true, false. And this was character A. Okay, so when you do D single square bracket 1, you're going to get back this entire train car. So when you say, what is the type of? Type of is list. When you do D double square bracket 1, then you just get that vector inside. You get the 1, 2, 3, and that's going to be type double. Here's another list. List 1 through 8, L1, list 1 through 8 has letters 5, 5, 4, 3, 2, 1. single square bracket gives you back the first train car, which is a list. There's no names here, okay? And so the way it distinguishes as a list is you see this double square bracket 1 appear here, and this indicates, okay, this is the element inside this train car, inside this list element. Whereas here I've got L1 double square bracket. So make sure you understand the difference between this. L1 single square bracket 1, L1 double square bracket 1. This one is the contents of the list element. Right? And this is just a vector. 1, 2, 3, 4, 5, 6, 7, 8. When we do this, okay, what is this? So ignore this single square bracket 1. This thing up here is this. What is the length? What is the length of L1 single square bracket 1? It has a length of 1, right? It's a train, but it's a train with just one car. So how long is this thing? It's one thing, right? So if I say, give me back the second thing, it just says that doesn't even exist. All right, you say, here's a train moving along that's just one car long. And you say, well, what's the second car? Well, there's no second car. There's no second car. So it says, you know, that's an empty list there. There's nothing there. Okay. Whereas we can say double square bracket, L1 double square bracket, and this says, okay, what's inside that train? What's inside that train is a vector of length 8. Then we can say, what's the second element in that vector of length 8? Well, the second element in this vector, the second element is the number 2. So this is fine. Okay, this is fine. And then if we were to do recursive subsetting here, it's equivalent to this, and that also works. That also works. Okay, what's going on here? Here is a list, L2. L2 is a list. And nested inside list, L2 is a list of 3 elements, but the first element is list 1, okay? So we've got a list of 3, and that first object inside that train car is its own little train, okay? So let me just kind of draw this, what L2 looks like. So L2 is a train of length 3. Inside the second train, we've got 10, 20, 30. And inside the third train car, I've got D, E, F, G. And inside this first one, I've got basically a train inside a train, all right? And this is going to be 1 through 8. This is A through D, and 5, 4, 3, 2, 1. Okay, this is what's inside there. All right, and again, all of these things are unnamed. So this is technically, this would be double square bracket 1. This is double square bracket 2. And this would be double square bracket 3. And within this would be double square bracket 1, double square bracket 2, and double square bracket 3. All right, and so if you can keep track of, understand the structure here, then I think these next slides will make sense. So we say, hey, what is the first element? We use single square bracket. The single square bracket is this entire box. This entire box, okay? The double square bracket 1, and inside that we've got double 1, 1, double 1, double 2, and double 1, double 3, right? So it's this entire box, and we've got the elements. It's basically a list. This itself is a list of length 1. So how long is this thing? L2 single square bracket 1 is this entire box. Okay, and what is that length? Okay, it's got a length of 1. Okay, it's got a length of 1. Okay, so this is L2 single square bracket 1 is this. It's a length of 1. Okay, so L2 single square bracket 1 is indeed a list of 1. Contained inside that list of 1 is a list of 3. Did I give you your second view quiz answer? Just, I've only given 1 so far, right? So far 1. Second view quiz answer is the letter D. D as in dog. D as in dog is your second view quiz answer today. Second view quiz answer today is D. D as in dog. Okay. Whereas L2 double square bracket, L2 double square bracket, what does that return? That returns the contents. That returns what's inside the box. I don't know how this works. Okay, I'm doing something wrong here with this. Okay, so when you do the double square bracket, it gives you the contents, which itself is a list as well. Okay, so L2 double square bracket 1 is a list. It's a list of length 3, but this is a list of length, and it's a list of length 3. Okay, so L2 single square bracket 1 is this, length 1. L2 double square bracket 1 is the contents, which itself is a list. It's a list of length 3. And indeed, when you ask for the structure of that, that's what it reveals. And so now when we reference these different things, I hope it makes sense what's going on. So when you do L2 double square bracket 1 and you ask for the first element, okay, L2 double square bracket 1, single square bracket first element, that's going to be this thing with 1 through 8. It's a list, okay? Whereas L2 double square bracket 1, double square bracket 1 is the actual vector. 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right. So we've got that. Okay. So I hope this distinction here between L2 double 1 single 1 and L2 double 1 double 1, that distinction there is clear. Okay, and so when we do L2 double 1 single 1 2, we're asking what's the second element here? There's no second element. That's why we're getting a null. When we ask L2 double 1 double 1 2 here, we're asking what's the second element here, and it's the number 2. So I hope all of these things make sense, right? And take the time and draw little diagrams for yourself to make sure you understand the difference for why we're getting a null here and why we're getting the actual value 2 here.
Wait, Professor, can you clarify again? Like, I didn't get the difference between L2 double 1 and single 1 and L2 double 1 and double 1.
Yeah. So I tried to illustrate this, right? Okay, do you understand L2 double 1 is the list? Is this length 3 list?
Okay.
That's good. Okay, so L2 double 1 single 1 says, give me back the first element of this list, which itself is just this box, is the box containing the vector 1 through 8. L2 double 1 double 1 is not the box, but the contents of this box, which is the vector 1 through 8. So this
So
here is a list of length 1, and this is a vector of 8. So the double one is what's inside the inside the list element. It's so again, when you use single square brackets, it's just pulling the entire train car. When you use double square brackets, it's gonna be the contents of the train car. There was a question. It says, when you do a single square bracket, will it always be a length 1? So the answer is you can technically, inside the single square bracket, you can put in multiple elements. So let me just kind of, so I've got L1 and L2, right? So here I've got L2 and so I can do L2 double 1 gives me this. L2 double 1 single 1 gives me a list of length 1. Okay. Now, what I can do is I can say I want 1:2, and I can do this. Or I want 2:3, and I can get the second and the third train car. So it's gonna, this is gonna be, what is this? What is the length of this? This has length 2. Okay, because it's a train with 2 cars in it. But if
in the output, why doesn't it show 2 and 3? Like it starts from 1 to 2 instead of.
It starts from 1 to 2 because these are unnamed. Okay, they're unnamed. It's just, it's, you know, just like if I did 1 through 100 here, okay, it starts at 1, right? And then if I wanted to subset this from the 5th through the 8th elements, then it will give me back the 5th, 6th, 7th, 8th elements, but it still starts numbering at 1.
Okay.
So it's always giving you the index position. It starts, everything always starts numbering 1.
Okay, got it, thanks.
Okay. Yeah, sorry, the L's and the 1s, they look similar.
Professor,
Yes.
if you do L2 double 1, single 1, then single 1, will that give you the list?
Yeah, it'll still be the list. It'll just be the same thing. So L2 double 1, L2 double 1, single 1 is this, and L2 double 1, single 1 is the same thing. And you can just keep doing this ad infinitum. It's just going to keep giving you the same list.
Okay.
It's just kind of like asking, okay, what is this? Okay, X is this. What's the first element of X? It's that. And then it'd be like, what's the first element of that? It's still 1, right? And we can just keep putting these in parentheses and asking what's the first element, and you'll just keep getting the same thing. It's not impressive.
Right, but basically that, like when you access that list, then you ask its first element, like it can just give you the list.
Yeah,
instead of
it's just
accessing the
box
content
itself. Yeah, it's just giving you,
Okay.
keep giving you this box. Yeah. Okay, we've kind of spent a little bit too much time on this. I got a lot more slides to continue. Okay, so if you've got named things, there is a difference between using single square brackets and double square brackets when you're using an atomic vector with names. Single square brackets will keep the names, whereas double square brackets drop the names. And let me just kind of skip ahead to out of bound indexes, okay? So here, L1 is a list of length 3. L1 is a list of length 3. If I do single square brackets and I say, give me the 4th element, right? Length of 3, there's no 4th train car. It says there's nothing there, right? It says a train car that doesn't exist. There's train car null, okay? On the other hand, if you say, give me the contents, right? Double square bracket says, look inside this 4th train car and tell you what's inside. Now we get an error. It says, hey, that train car doesn't even exist. I can't even I can't look inside there, okay? So now I get subscript out of bounds. So here, when you say, give me the fourth train car, it says, you know, that train car, this list element doesn't exist, it's a null. When you say, give me the contents of that thing, now it gets angry and it says subscript out of bounds, okay? Similarly, if you try to subset using null or 0, you get an empty list. If you say, give me the contents of this thing with null, it says, yeah, you're not allowed to do that. Okay. I gotta work fast. Okay, talking about subsetting a matrix. Okay, I think we're familiar with subsetting a matrix. So here's a matrix, 3 rows, 3 columns. I've given the columns names A, B, and C to kind of distinguish this rows 1, 2, and 3. And if you want to subset a row, you can just say, I want the first row, I want the second row, I want the third row with a comma there. So you can just say, I want the first and second rows, comma, all the columns. You leave a blank there, and it gives you the first and second rows, all of the columns. You can use true, false vector, logical vector. True, false, true. I want columns B, A. So this will give us the first row and the third row, and it gives us the column B and column A in that order. If you say, I want none of the rows, 0 rows, everything but the second column, indeed, we get no rows and all but the second column. When you subset a matrix, okay, and you say, I want something like the first row, it doesn't subset the matrix and give you a matrix that is 1 row and 3 columns. It doesn't give you a 1 by 3 matrix. It simplifies down to a vector. It simplifies down to a vector. So if we ask, is A a matrix, or is A a vector? It's going to say no, and it recognizes that it's a matrix. But then when you say, I just want the first row, it simplifies to a vector, and indeed, it is a vector. Here is a matrix with the characters A through Y and a 5 by 5 matrix, 5 rows, 5 columns. And again, a matrix is really just an atomic vector with dimensions applied to it, right? And so when you think of the vector, it's really just a length 25 vector. And so you can treat this as an atomic vector, and you can just say, hey, what's the 8th and 9th element of this vector? So notice I'm just asking 8th and 9th. I'm not asking 8th and 9th row. If I put a comma between here and here, then it would be the 8th and 9th row, and that wouldn't work. There's no 8th and 9th row. But here I'm just saying, give me the 8th and 9th elements of the vector. So it goes down the column, 1, 2, 3, 4, 5, 6, 7, 8. The 8th element is H. The 9th element is I. And it'll say the 8th and 9th elements are H and I. With a matrix, you can use another matrix to subset the matrix. So you can think of this as, so here's a matrix, and we can define every point here using coordinates, right? We can say G, second row, second column. Q is second row, fourth column, right? And so we can use a matrix with 2 columns, basically a row coordinate and a column coordinate, to tell us which values we want. So here I can say, I want the element in the first row, 5th column. What is that? First row, 5th column is the character U. I want third row, first column. Third row, first column, character C. Second row, third column. Second row, third column, L. Okay, and we can go through, and I can say subset the matrix with these elements, and then we will get the matrix UCLA. Okay, or the elements U and C and L and A, because we've told it, I want the element in the first row, 5th column. I want the element in the third row, first column. Okay. Same thing, you can apply it to higher dimensions. So here's an array in 3 dimensions, 2 rows, 3 columns, 2 layers. And I can say, I want first row, second column, first layer. First row, second column, first layer, element 3. Second row, third column, second layer. Second row, third column, second layer, element 12. We'll get that. last thing, we're going to talk about data frames. And before I get into it, let me give you your final view quiz answer for today. Final view quiz answer today is the letter E. E as an elephant. E as an elephant. Okay, I'm going to try to get it through as many slides as I can. I might run out of time. I might go a couple minutes over 11:50. If you need to leave, you need to leave. So no worries. Okay. So a data frame, remember, internally, a data frame is stored as a list. So you can subset a data frame the way you would subset a list. But the data frame also has this two-dimensional structure. And so you can subset it like you would subset a matrix. Okay. And when you do it, they're going to kind of behave like matrices. So, so here I can subset kind of like a matrix. And I can say from the data frame, I want all of the rows. So notice there's a comma here. I want the rows where this statement is true. This is a logical statement. It says take column Y. So df $y, I'm subsetting it. So we're just looking at column Y. And then we're going to run this operator. We're going to just say divide by 2 and find the remainder. And if that remainder is 0, so meaning it divides by 2 evenly, so this is an even number, then if that's true, then I want it. So we look at column Y, and then 4 divides by 2 evenly. So we're going to get that row back. 3 does not. We don't get that row. 2 divides evenly. We get that row. 1 does not. So we don't get that row. And then there's comma 0 or comma space, meaning we get all the columns. So we're going to get this first row here, 1, 4A, and we get this row, 3, 2C, because it's true for these columns Y. What about subsetting the matrix or subsetting the data frame like we would do a list? Okay, you can just say, I want, again, think of the list. And the data frame is basically a train, and the elements of the list are the columns. Okay, so you're just going to say, I want train car X, I want train car Z, which is basically, I want column X and I want column Z. And you can subset the data frame that way. You can get the same result subsetting like you would a matrix by putting in this comma. And now we're saying, I want all the rows, and I want column X and I want column Z. And you get the same thing. So these two things are pretty much the same. But when you try to do it with rows, it's going to be different. It's got to work this way, right? So here I can say, I want row 1 and I want row 3. I want row 1, row 3, and I put in a comma to indicate I'm talking about, I want row 1 and I want row 3. I want the first and third rows. If I leave off this comma, what's going to happen? If I leave off the comma, now it thinks we're treating it like a list, and it's going to say, I want the first train car and I want the third train car, which is going to be, I want the first column and I want the third column. So if you leave off the comma, you're not going to get rows 1, 3. You're going to get column 1, X, and column 3, Z. Okay. So I want to make sure this distinction is clear, that including the comma, putting the row numbers, and then the comma will select indeed those rows. But if you leave off the comma, you're going to end up selecting those columns. With named columns, if you do kind of, if you select the column only, it's going to simplify it. So if you use kind of like this $ notation, df $X, you just say, I want column X, it's going to simplify it and return a vector. And it's not going to preserve the data frame structure. There's a few more things about simplifying for preserving. I'm running out of time, so please just look over these notes over the weekend on your own to kind of understand the difference between simplifying versus preserving. And it's kind of the idea of, is it going to remain a data frame or a matrix when you drop the columns, or is it going to simplify down to a vector? And if you want to kind of preserve the structure of a matrix when you select just one row in a matrix, there is a way to do that by saying drop equals false. So anyway, please make sure you take a little bit of time this weekend to look over that. I want to just point out a couple common things that go wrong when you do subsetting of a data frame. All right, and I know it's 11:50. I'm going to go maybe 2 or 3 minutes over, and if you need to go, that's fine. So here's a simple data frame. This is a built-in data set in R. It's called MT cars. It's motor trend cars. It's got these vehicles. It's got things like miles per gallon, the number of cylinders in the engine, and things like that. So here I'm trying to select the cars where the number of cylinders is less than or equal to 5, right? So I'm taking this column cylinders. You know, some cars have 6 cylinders, some have 4, and some have 8. And I'm trying to say, I want the cars where the number of cylinders is less than or equal to 5. What did I do wrong? I'm getting this error that says undefined columns selected. What I did wrong was I left off the comma. Okay, when I leave off the comma, this comparison, cylinders less than or equal to 5, works, and I'm going to get like false, false, true, false, 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 and stuff like that. The problem is because I left off the comma, it thinks I'm talking about the columns. So perhaps there's 30 cars, and you get false, false, true, false, 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 true, false, true, whatever. And maybe the 16th element is true, right? It's going to think I want to select the 16th column. I don't have 16 columns. And so therefore it's saying undefined columns selected because I didn't put the comma in there. So it's thinking I'm just trying to select columns. So if you put in the column comma there, then it will work. Okay. What about this example? I'm saying I want cylinders equal to 4 or 6. I want the number of cylinders equal to 4 or 6. I have the comma there. And it looks like it's working, except I look and I say, no, I'm still getting cylinders with 8 cylinders in this thing. Why am I not getting just 4 cylinders or 6 cylinders? What went wrong?
Don't you like have to put the empty cars dollar cylinder on like the other side as well? Like
yes. So what's going on is this or statement, right? This or operator is going to coerce anything that's not a logical vector to be a logical vector. And so this is a logical vector. It's going to be false and true. It's going to be false for the 6s and true for the 4s. It's going to be true for only 4s. But then on this side, this 6 next to the or operator gets coerced. What is the coercion rule? Anything that's not a 0 gets coerced to true. So here I have this logical vector of falses and trues. On this side, I just have or true. And so this is going to just become true for everything. Okay. And so it's going to still be true for even the 8s. So what you have to do is you have to do the logical vector empty cars cylinders equals 4 or empty car cylinders equal to 6. So now you have 2 logical vectors, and then you can do trues and falses. And now it works correctly. We've got it only returns vehicles where the number of cylinders is 6 or 4. Okay, I wanted to just point these 2 examples out, and I appreciate your patience with sticking around after class just for a few extra minutes. But anyway, we'll wrap up here. This will be the end of today's lecture. Have a good weekend. Please do review the notes for the pages I wasn't able to cover, and we will see you guys on Monday. So have a good weekend and see you guys later.